Hey everybody, we're we're back again, 2 weeks in a row. Check that out. It's like a
That's it.
miracle.
We're back on track.
Well, 2 weeks of evidence of back on track. Anyway, that sounds like the audio is working.
Yep,
It's like a
sounds good
miracle.
to me. We're
It's funny. So we're having a little bit of like prep just before we started, and in YouTube you get like a little live preview that looks very potato quality, and I was
yeah.
thinking, oh no, this is not good. Uh, but luckily, that's not a problem anymore. So um, hopefully everything is working fine for everyone. Shout out if it's not. Say hi. Shout out. Far
Say
out. What
hi.
am I like? Just guys, just shout out. Just shout out.
Just give
Um,
us a shout.
yeah. Hopefully, like it didn't like send out a different link once the stream actually started.
No,
You
I just retried the link and it worked.
cool. This is the joy of the fun we're
The
having.
joy of trying a new platform.
Yeah, we're still getting used to it. It just said there was like 5 people waiting, and now there's like one person more. Oh well, you know what? It doesn't matter. Three concurrent. Jacob, one of those has to be us,
One of them.
or both of them. Cool. So I suppose so. Interesting day. Three Victorian hospitals got. Just for context, we normally do a little bit of chat just before we get started. Just wait for some. Give everyone a chance to rock up.
Yep.
So three Victorian hospitals like got hit by ransomware.
Ransomware, yeah.
Yeah.
I read about that.
I don't know if I saw if they knew if they were targeted or just there was another campaign and the usual state
It
of like
happened to spread there, yeah.
corporate IT. Um, like it's the sort of thing where hard shell soft center. So organizations put all these great controls in, like email filtering and firewalls and proxies. But if those don't work, like it's game over.
Yeah.
The old armadillo kind of soft underbelly, hard
There's
shell.
basically nothing else in place, yeah.
Yeah, the joy of life. Everyone is currently seeing a blank. Oh, there we go. That should put it back. Uh, Logged in with my super awesome password. Um, so I suppose today, something a bit different. I thought it'd be cool to kind of do a bit of Python stuff. So specifically kind of go through kind of Python for security people or whatever, whether it's, you're just writing little scripts or you want to write tools or whatever. So I'm going to open up this. So there is a tool called gobuster. I'm just going to,
Which we have used many times on Hack the Box
yes.
machines.
So if I've got a server running on my network at home. Oh gosh, if I can like type. So this is gobuster. Dirbuster's another tool. So gobuster's I think based on dirbuster. Runs a bit faster. It's a bit easy to use because it's Go, which not Java. Not that anything's wrong with dirbuster. I think dirbuster CMD was fairly fast, but the GUI version was always a bit slow.
Yeah.
One, two, oh no, people are seeing the layout of my internal network.
Oh
Um,
no.
so we're not going to smash my computer with 100 threads. We're just going to go with a nice gentle two. So some things you might know about GoBuster. I forget what the K flag is. You remember, Jake? What's K? Or don't you remember? Are you typing?
K is ignore certificate warnings.
Yes, there are none here because it's HTTP, but I've got -u for URL, which is just a box on my network. -w for the word list. -t is for number of threads, the output, and check for some obvious extensions. And so if you let that go, what it didn't like was I had done something very wrong there, and I don't even remember what it was. Quick, Jacob, help me.
You have to add the dir now. So you got to do under straight after gobuster. They changed the syntax for it.
Oh,
So that's the old syntax. You need to do dirbuster dir to put it into like directory mode.
oh, gobuster do
Yeah,
like that.
space dir, I think.
Oh, okay, yeah, sweet.
Um,
So
because you
that,
can choose it a lot of different modes now, and directory mode is sort of how
yeah,
it used to run.
that makes sense. It's been a
Yeah.
while since I've used gobuster, and also I started updating my Kali, so these things come out of nowhere. So anyway, I thought this is like an easy enough little kind of tool to try and throw together. Um, Morals are arrived.
Yeah,
Hey,
Moral's here.
you're back.
He was not happy that we moved to YouTube.
Yeah, we moved to YouTube. Yeah, you can't go to Twitch for all your entertainment now. um, welcome. We are back. Anyway, so I thought, this is probably, at least in its basic form, a simple enough little tool to quickly throw together in Python and to kind of teach you guys some Python. So the finished product is here. I've called it dirspam, and actually it's dirspam 2 because I created a dirspam project and pointed at the wrong version of Python, and couldn't be asked figuring that out. So what we're gonna do is quick few cool things about. So I am a fan of Python. I don't know if any of you have used it much, but certainly it's cool because it's pretty straightforward to learn, fairly easy to get going. It's a decent user base, so if you Google for how to do X in Python, you'll generally get an answer. It might be for Python 2, thanks to Google, but Python 3 is what you want. Has a pretty decent standard library, so all the stuff you get out of the box without having to install extra stuff. Although if you do want to install kind of add-ons, it's relatively easy and there's a ton. Pretty flexible, so if you've ever used Java or .NET, kind of you're stuck in a particular paradigm of needing to throw everything into like namespaces and classes and structuring things a very specific way and try catching everything because that's the way they work.
Strictly typed variables.
Python lets you do all of that or lets you not. So it's really good for just chucking stuff together. There are other languages though that are like that, like PowerShell certainly lets you throw stuff together. PHP, if you want to use PHP, stuff and so forth. And if you're ever in like a CTF or pen testing scenario or red teaming or what have you, Python exists basically on every single Linux server that's out there. Sometimes it's Python 2. We're doing Python 3 today. There's really not a ton of differences, but there are some kind of bits and pieces you have to figure out.
Hey, Grub.
Grub's arrived. But, they mostly just relate to some syntax and different functionality, but generally you can kind of work backwards to Python 2 if you have to. So for our gobuster clone, so I suppose I'm using PyCharm to kind of do this stuff. So PyCharm's like a Python IDE, integrated development environment. So if you've ever used Visual Studio, it's kind of like that for Python.
Yeah.
Or if you've ever used Visual Studio Code or Atom with like all the add-ons for languages, it's probably more like that. I just like to use it because it handles all the tedious stuff. So, for example, I'm just going to create a new project to start from scratch in, and I'm going to call this stream just because I'm being unoriginal. We want to use a virtual environment, so Python you can use it in two different ways. So one of them is you can use the system Python. The challenge with using the system Python is if you install extra packages, they get installed for everything. If you upgrade a package, you might break your operating system because sometimes they get pretty finicky. Virtual M's depending on how you've got it all set up. But they effectively take a copy of the system Python, stick that in a different directory. In my case, it's you get chucked in a subfolder of my project. We can show you that in a sec. And that has the Python interpreter and all the other kind of utilities you need, like pip for downloading other packages. And then PyCharm sorts it out for you, but you can do it yourself as well. There's a couple of scripts in there that change a bunch of environment variables, so you're using that Python instead of system Python. It's a great way to not break stuff, and you can have different projects at different Python versions. Like I'm going to use 3.7. I've got 3.6 installed, 2.7. I think Python 3 and Python 2 are just aliases for whatever's latest, or whatever's set up, because 3.6 might actually be the default operating system one. If I go create, I'll create it in a new window. Why not? And that all looks like it worked properly. So if I go Python version, just for example, so normally if you've got Python 2 installed, it's going to say it's Python 2, but you can see the VN here. That's just what virtualenv does when you run a virtual environment to tell you that you're doing that. So Python 3.7.3. So fairly recent. Anything from 3.6 up should work in this. I'm not using anything super fancy. So to get started, we're going to, I suppose, create the first bit of what we want to do, which is let's make a web request. Because at the core of gobuster and dirbuster is the ability to request something from a website to see if it exists or not, or if it's accessible or not. So, and here's the Venn folder. It's just like what the Python kind of system folder would look like as well. So, new Python folder. Fairly straightforward. Just calling it dirspam again for the hell of it. So, to make a web request in Python, I'm going to try and keep this to using the stuff you get default, which does mean there's a little bit of tedium because URL-lib, which is what you use in Python natively to make requests, isn't as easy as requests, which is just a wrapper for URL-lib, but it abstracts away a bunch of the pain. But if we go import URL lib.request, so if you've ever done any other programming before, you'll kind of know what imports are. Import, modules and classes and functions and variables. In Python, everything is an object of some sort. So a class, a function, a variable, they're all importable. Whereas other languages, you can really only import like classes or specific structures. So
you have to create it as a structure that can be imported.
Yeah, so you could literally just have a file with a variable in it, which, like name equals Bob, and then in another file have import name from, and then the name of the file or the module you want to pull it from, and it'll just pull that variable. One of the other quirks with Python and the way imports work is it actually parses and executes the code. So if the module you're importing from has like code that's not contained within a class or a function, then that code runs. And we've used that before. There was at least one Hack the Box that had that as the exploit, was you had access to change the content of one of the classes or one of the modules, and you got control through that. The other thing to understand is that imports kind of work a similar way to DLLs on Windows. So they look for DLL in the same directory, and then the DLL in a specific Windows folder, and then the DLL maybe somewhere else. So it's kind of like that setup. So anyway, all that to say, we're importing that particular library, and now we're going to make a request. So to do that, response equals URL lib.request does it just open? Gosh. Great at remembering things. Yeah, it's URL open. I actually normally use requests, and then when I was throwing this together last night, I was like, no, I'll do this without using extra libraries. And then we're going to go to HTTP 192.168.0.138. So what we're doing is response is a variable, and this is just a function. So this will go do a get request to this location and dump a bunch of stuff back into response. And then it's... so we just then need to go print response dot read. That's right. Cool. So what we should have, if I run it down here, I mean, I could hit the play buttons up here and stuff, but I never have. Man, it's funny. I use PyCharm, and then I probably don't use it half as much as you should.
You don't use like any of the debugging capabilities or anything.
I've used the debugging stuff before, but I'm
purist.
I'm a rank amateur. Like, I use it like you'd use Visual Studio Code.
It's
it's
basically a glorified notepad for you.
Yeah, you don't have to install all the extra stuff to get like Python kind of linting and stuff going. So quick, I'll check YouTube.
It's a glorified notepad with linting.
Yeah, indeed it is. And there we go. We've got our that's our HTML back. So that's something. In theory, we can then go. I think it's response.code. I'm gonna just do this blind. If this works, I will be amazed. Yeah. Okay. My bad. It's not a function. It's just a. Yeah, so we get a 200 back. That's cool. So at that kind of is the core of what we're trying to do with seeing if things exist on a server. Like, do I get the right response for this? Or if I just try and throw something random in here, we should get an because this is URL lib. So the requests library treats 404s and 200s largely similar. So it goes, a 404 is a valid request. It just might not be the request you want. So you handle the error yourself. So you can check the error code I give you, but I'm not going to throw an error. Whereas URL lib throws an error, which is a bit...
Yeah, an exception as well. Well, some people might know it as an exception.
Yeah, so in Python, there's differences between errors and exceptions. An error is meant to indicate you probably should handle this and continue operating normally, and an exception is like a get the hell out. That's my understanding of the two. The reality is you can kind of treat them the same and try accept whatever to get around to them. Just for demonstration's sake, install requests. So there is another library called requests. So if I just hide that for a second and go import requests, and then we go response equals requests dot get, and then it's, gosh, my typing skills are on point, Jake.
Yep.
Oh yeah.
That's all right. It's because it's stream time. All the peer pressure of 5 million viewers.
No plan survives first contact with the enemy, I think. Man, I'm also not in the, when we're streaming every week, I had momentum and I could be get on my high horse, but I've just lost it, which is probably for everyone's benefit. Oh, wait a second. And that is status_code for requests, not just code. So this is just to show you requests, and requests gives you a nice 404. So
yeah, it doesn't throw an error. It just gives you the output.
Requests would be easier to use, but at the same time, if you were deep inside someone's corporate network on a Linux box with at least, let's say it had Python 3.6 because they update stuff, if you might not be able to use requests you wouldn't be able to use pip to get it. potentially because there's proxies in the way, potentially because you don't have the right level of privilege, potentially because pip's not even installed because it doesn't come by default.
It could be loud and trigger some sort of
Yeah.
IDS or firewall to say, hey, this computer just tried to install a library, that sort of thing.
Yeah, so you could try and get this on there yourself. If you had a reverse shell and could pipe data over, you can do it that way as well, but we don't actually need requests. We can do this with URL-lib. So we've got our use cases where now we have to handle some errors. So normally in kind of like how to program things, you don't jump straight into let's do stuff with try and accepts, but we will. So what we are going to do is try. So this is error and exception handling in Python. So we are going to try this. And we are going to accept. In other languages, it might be called try catch.
Yeah.
Accept, and we want to accept. Oh, that's right. We need to import. So this is one of the other things in Python. I think it's similar in Java as well. Is you actually need to import, and maybe .NET. I'm trying to remember. My Java days were kind of a little bit behind me. But you need to import the error classes in Python at the very least. So accept HTTP error as E. So
yeah, in .NET, so the fact that you've imported URL lib, you also get all of the error classes and stuff as well.
Yeah. So if I had only imported URL lib, I could say accept URL lib .error.http.
Oh, yeah. Okay.
So there's a bunch of different import magic going on. So you have import URL lib.request, URL lib.error. I could go import URL lib. Let's pick parse as parse, and then I refer to this as this, so that's aliasing it.
Yeah.
So there's a bunch of other options. So yeah, in this case, you're going from this module, import these specific things, and because in Python everything's just a hierarchy of like objects. It's kind of at the highest level. It's what everything is. These below them could have sub things that you could go from URL lib.error.htp error import whatever you want.
Yeah.
If it exists, So accept HTTP error, and we just go print OD. And then we're going to catch. So a HTTP error will catch HTTP error status codes, and then URL errors catch I couldn't connect to the server. So when I was working on this last night and I was talking to Jake, I jumped over to a different box in the box I was originally developing on. So I'd originally threw this together on a Windows box, and I thought, no, I'll do it on Linux because there are some problems with how Windows does things like threading, which I was thinking about demoing if we have time. Copied over, forgotten I'd had an accept block that just literally said, if this happens, quit. So it just was like, quit. And then it was happening, and I was like, why is my script not running properly? And then I realized it was because the web server I'm deving against was set to only respond to the local IP address. So print. That's not OD. What would it be? OD. Jeez.
OD.
Print. Just so I know there's a difference. Okay, so and we want to stick print response code back up here. And if we run now, we get an OD because it was a 400. So we can also go print E to print our error out so we know what happened. So this is the fundamentals of error handling in Python. Surprisingly enough, HTTP. Oh, I put that one in the wrong place. Surprisingly enough, for security stuff, so I was I had to write a bunch of PowerShell to start trying to do like domain name kind of scanning and stuff like that, and then seeing where servers redirected because there was a bunch of redirects going on. And in PowerShell, you have to override a lot of default error handling behavior to be able to do what you want to do and get the information you want to get. So, surprisingly enough, in security, knowing about accepts is useful. There's also a finally, which I'm pretty sure just executes every
It
time.
runs no matter what. Yeah.
I mean, I don't really use finallys, but if you need to clean stuff up after, so no
it's
matter
pretty rare that I've used a finally and a try catch or a try accept. Yeah.
So if this works, this will run. If one of these gets hit, this will still run. So you'd use it to clean stuff up if stuff was leaving a mess. But
the finally should still run even if there's no errors as well.
Yeah. So I've never had to do that. So anyway, now we have something that'll just tell us we hit a specific error, but it still doesn't give us the code. So what we want now is a variable to store our response code in. I'm just going to call it code. Another thing in Python that I'll get onto in a sec is you can do fun things with it's weakly typed. So we want code equals response code, and then we want, we can get rid of that, code equals e.code, and then this one we will just quit because it indicates that the server's not responding. But with the uh-oh there and the error, I know if something's gone wrong now, whereas I didn't when I was like agonizing about this. So print code. So now I should get a nice 404, and if I get rid of this, I set it to a file that I know exists, index.php, I get a 200 without the extra 404 error bit, because I'll just leave that there for the minute. So one of the things in Python is e.code and response.code are integers. 404 is a number. I can quickly test that by trying to add a string to this. It's going to freak out and go, yep, unsupported operand. You can't add a string and an integer together. In Python, to concatenate two strings together, you use plus, but also to add two numbers together, you use plus. So it's gone, I don't know which of the two operations you want to do. So to be able to do that, you need to cast the integer to a string. However,
so the advantage of URL lib over requests is if you're somewhere where you don't have the ability to install libraries.
Yeah. So I'm using URL lib to be kind of like a, you know, you're in a living off the land scenario where you've popped someone's server in a legal manner because it's a red team or a pen test or a bug bounty. And there's Python 3 on the server, and that's all. You know, like it's a Linux box with its default Python 3. So you could go and do requests. So I demoed a bit earlier just installing requests and going, requests makes life a bit easier because it doesn't throw hard errors on 404s, whereas this does, like URL lib does. So one of the things to note is the code variable here, I'm setting it to an empty string, which means its type is being set to a string, but here I'm assigning an integer to it, and then and here I'm assigning an integer to it, and here I'm printing out an integer. So
in most strictly typed languages, you would get a compile error, like you wouldn't even be able to run the code.
It'd be like int code. Python does have type ints. I've never really used them. In bigger, more organized projects, you'd probably want to use them in quick scripts. But unlike other languages that are, I forget the other one. Oh, this is dynamically typed. It's not weak typing. It's dynamic typing. So types are assigned at assignment. So if you give a string to a variable, it'll go, that's a string. This variable's a string. If you give it a number, it'll go, this is an integer. It'll let you change the type as you jump through, like I have here, but this is now an integer. It's not a string. It's not a float. It's an integer. JavaScript is weakly typed in that a given variable is ambiguously typed and could be used in multiple different contexts. So it'd see 12 if you had a variable with the value of 12 and you used it in addition, it'd see 12. If you tried to add it to a string, it'd see it as a string. It's a bit...
Yeah.
Whereas Python's not like that, but it is dynamically typed, which means if you forget what type of variable it is and you try and stick it in the wrong place, stuff breaks. Again, type hints, which are for IDEs and the runtime to go, hang on a second, you're trying to assign something to this, you shouldn't. They're useful, but I don't really use them. Anyway, so we're at the point now where we get a meaningful code, so a 200 or a 404 or a whatever. Now we kind of need to throw together kind of just a brief and non-overly comprehensive list of interesting codes, response codes. You'd probably
rough response codes that mean there could be something here. Go check it out.
Yeah, you'd probably want to make this more complete, but these are all the ones. So a 200, 203, 206, 301, 401, 403, and 405. Like, yeah, they indicate something might be there. I then had these ones I called borderline codes, which were like 400s and 500s, because they might indicate that there's actually an endpoint there and you've just given it the wrong thing. Or they might
the server has errored out.
Yeah, or they might just be something that, if Apache or Nginx doesn't like something, they give you that. Nginx, also, as I found out just before, gives you a 403 no matter what you try and request if you're coming from an IP it doesn't like. So if you've set up the allow directives to allow this and then everything else block. So, okay, cool. So we've got those, and now we need to compare. So a way to go is the response we got for this endpoint something we could be interested in or not? So for that, we're going to get onto logic, some basic logic stuff. So the joys of ifs and elses. So if code in what did I call this one? Interesting codes. Print. I founded something. Elif code in borderline codes. Print. I maybe founded something. And then finally, else, print, nothing. Cool. So then I should just be able to... Sweet. So 200, it found it. So if I give it some garbage, it's going to come back with a... Better come back with a nothing. It does not be very sad. So hopefully you all get the idea of what an if, else, and stuff like that is. Couple of things in Python. So an elif is an else if. It's just one keyword by itself. If you try and do that, it does not work. You can't do else space if. It's always just elif, which got me... Every time I jump over to another language for any period of time and come back, I always have an adjustment period coming back. One of the other things is a handy shortcut in Python when comparing things. So I used to do this dumb thing where I'd have to write a loop and go for each thing in interesting codes. If this equals to this, set some other variable to true and then check that at the end to see if I found what I needed to find. But in Python and a bunch of other languages, you can kind of just use this syntax where it's just like, if the value of this is in this list of other values... These are lists in Python, by the way. Lists, kind of arrays, I suppose. Pythonistas call them lists. I'm sure someone will tell me why they don't call them arrays, but anyway, it's a list. It could be a list of numbers, it can be a list of strings, it can be a list of other objects, it doesn't really matter. But this is just comparing and seeing, hey, is there anything in there? Yes or no? And at the end, we get what we want. So if I just go to where we are next. So the challenge, I suppose, with where we're at now is... If we wanted to kind of do this for a second URL, we've kind of got to do this whole, let's copy all of this, paste that there, do some other URL. Oh, sneeze. Yeah, and I had to do it, so that gives me my 404 for the first one and a 200 for the second one. But that gets really tedious. I don't want to do that. Let's just get rid of everything I just added to neaten it back up. So what we want to do is have a kind of a neater structure. So in order to make things a bit more repeatable, that's where you start to use some functions and classes and whatnot. So I'm going to, for the sake of expediency, not going to write all this out from scratch. I have something I prepared earlier. I just need to change this. Okay, so all I've done is I've put all of the kind of stuff from before in a class. So a class is, if you've ever done any other programming before, you'll know what a class is. It's just a way of kind of collecting together related properties and functions. In object-oriented programming, you would go, there is an animal class, and there's a subclass of that. There is a dog class, and then the leg value of the dog class is 4 legs, and the leg value of the human class is 2. But the human class also has arms, and there's 2, goes on and on and on. But this is the way of chucking stuff together. The step in between where I was last and this is, in theory, you could do all of this without the class. I just chucked it in there for demonstrative purposes. These are still here. These are now class properties. So to access them, you'd go like, I've got an instance of it here. You'd go like dirspammer.interesting codes, and it'll give you back that value. So these are like class level variables. So this is where scope comes into play. So def init self, so the 2 underscores in the init are what are called the constructor. So when you create the class, so I'm giving it a value here. I'm giving it the server to try and connect to check stuff. That is the constructor that function that gets run when you do this just on the class is the constructor. So it's like run this when you build it and set this value that I gave as this to this variable here. In Python, when you're inside a class and you need to refer to something in the class, you've got to go self.that thing. It's just a Python quirk. Notice also in all of the functions, it just really means pass the instance of itself through as well. It's
kind of like a scoping.
Yeah, I know what it's one of those things where I completely understand how it works and I completely suck at explaining it. It's like I don't know, it's like heavy philosophy or something. Either way, it's just knowing that if you're in a function inside a class, you need to refer to class level things with self dot in front of it. You can do the same thing in Java, but you don't need to because Java kind of has some stronger links with bits and pieces. .NET as well. Presuming you can do the same in .NET. You know .NET better than I do. Anyway.
Well, because .NET relies on the namespace, and the namespace is at a class level. So say if I was in a class and I typed base URL, it would look at the class's namespace and go, yep, that's in this class. And then if there was a base URL variable somewhere else in the application, it would probably be in a different namespace, and then everything would be fine. So it's almost like a combination of, I guess, scope and namespace in sort of one variable or one sort of idea in Python. Yeah.
Well, it's because these are like the reference class level things, and these actually get run, and you need to pass the instance of the actual thing back through it. It's the sort of thing to go and Google and learn more about if you're interested. Otherwise, it doesn't really matter then, other than knowing you need to do it. And finally, I've thrown this function together. check URL path, so self and word. So you can give it a thing to go and find. So I'll get that to a sec, but this is basically the code we had before. So response code, the URL to query. So because we already have the base URL set when we create the class, we get we can just throw together self.base URL plus the word that we're going to give it down here, and it'll create the full URL for us out of that. Then we try and request that, and then if we get any of those errors again, we handle those, and then we print out a bunch of stuff. And then down here, we actually instance the class, or instantiate. So variable called dirspammer gets assigned this instance of the, well, this is where we kind of create the class. So we're saying, hey, when you create the class, again, run that constructor or the init with this, so that when we get our instance, base URL set with the URL. You don't have to have a constructor in a class as well. I just kind of threw it there to demonstrate that they exist. And then I'm running it 3 different times with 3 different words, so to speak, or 3 different inputs. So if I try and run it now, sweet. So index.php gave us a 200. Blank, which is this one, gave us a 200 because that's just the root page. I click on that, like just that. That's just what I'm running because it was the easiest thing to throw together. Index.php and blank just go to the same thing, and this one gives me a 404. So this is like a little bit better now because we don't have to copy this whole block of text every time we want to request. But the challenge here is we still have to create every one of these for every single thing. Like that could get every single word. Imagine if you wanted to test 1,000 words, that'd get pretty tedious. So I'm just confirming what the next step is. I might also do another copy pasta special. Again, from what I prepared earlier. Just given we like to try and keep these things to roughly an hour or so. So rather than watch me type stuff out and typo things. So this is almost the same. However, you're noticing... Actually, I'll need to copy this word list from this one to this one. Yes. Sweet.
Nice.
Yes. So there isn't too much difference, except you notice down here, I'm not like saying, hey, here's a word to check, here's a word to check, here's a word to check. I'm just going... Here's an entire word list. So all I've changed is... Well, I've changed a bit. So in the constructor, it now takes a second argument, the path to our word list. Then it runs this word list function, so self.load word list from that word list path. And all that does is populate this empty list here with every single word split by a line. I realize I'm just going to have to pop over to the other one. I've got a lot of stuff open. I just need to grab this bit because I originally did all this on Windows, so there was some problems with formatting. That one can go, and here we are again. So line.rstrip just removes everything that it needs to remove. Yeah, that should be fine. So all this does is open the file that we give it, so /wordlist.txt, and then for every line in that word list, because it's just one word per line, put that word in our list of words. Then what we do is we run this other function called check word list, and all this does is then grab that list. So it takes no arguments, it just grabs the list at the class level, so self.words, and then for every single line in that or word in that, self.check URL path and then some more safety, like removing white space and stuff that this actually solves for, but I'll leave that there anyway. So in theory, that is not what I wanted to see, because
You're creating localhost
to change that. But it's a good demo of, like, in the final version, I'd set this one just to say quit, and I was like, this isn't working properly anymore. I couldn't figure out why. Yeah, so there we go. We've run through 1,000 or so words relatively quickly. This is, at the moment, not doing any parallel processing. It's just running through linear. So when I was building this on Windows, it was heaps slower than it is on Linux. And I don't know why. Must just be because of the way the kind of underlying C code in Python works on Windows. Also, multiprocessing didn't work properly on Windows, which is something, again, if we have time, I'll get to. Anyway, so that's kind of the next level of complexity. So that's, which is useful. So that kind of gets us to the point where now all you have to do is edit two things in a script, and now you're checking. I have at the top of the word list, I've got like a few things that'll obviously trigger, and then I just literally grabbed the top 1,000 words in English and just chucked them in there. So with a few changes, we've gone from I have to keep copying and pasting this bunch of code to now I just have to keep copying and pasting this function call to all I need to do is point at a word list and I can check. Again, dirbuster and gobuster let you start to set options like, hey, for every word, check these file extensions to see if they exist, and you can do DNS checking, and I'm not worrying about HTTPS and handling invalid HTTPS certs, although they're all relatively easy to sort out. You just need to go ignore them. But anyway, so the next step, wouldn't it be nice if when we ran this, we could just say the IP, we don't have to edit the script, we can just say the IP and host name. So for that, we're going to use, not IP and word list. So for that, we're going to use something called Outpass. So we should just be able to do it like this. Yes. So Outpass. So Outpass is a library for kind of grabbing arguments from the command line. So again, another happy bit of copy pasta, but
yeah. So in .NET, like the arguments and stuff come out of the box when you create a new solution. Arguments are already there.
They do in Python as well. So you can go import sys, and then go thing equals sys.arg.
Yeah, argv. Yeah.
And then 1. Because sys.argv0 is always going to be the name of the script, because this is the args passed to the Python interpreter, not the args passed to your script. So you always have to start
.NET works the same way. So arg0 is always the application, like the name of the application, not the first argument. Yeah.
So you have to start at 1. And if you've got, say, flags, so you've got like U for URL and then the actual URL, sysargv1 would be you and sysargv2 would be your actual URL. Which gets pretty tedious trying to parse all that, because then you go, is this one the flag? Okay, is this value after it? Or you can use argpass, which I swear argpass used to be a library that wasn't core in Python, but now it is. So all you do is you have to set up an argument parser and then argpass.argument parser, which is just, so this is the argpass module, and this is a class within that module that we're now instantiating. One of the things, so Python doesn't ever enforce syntax, it's all suggested, although if you use this or Visual Studio Code or Atom with any of the add-ons added, it'll wax lyrical about, pep whatever, so Python something, I forget what PEP stands for, but classic one is, or maybe it's not there because I need to do it with functions. If I add too many so here we go, it goes pep8, too many blank lines. So I think pep8 was the kind of Python kind of standard for a lot of the syntax. And so part of that syntax is for classes, like the name of the class is capitals. So I've done that up here as well. It's camel case is where the first letter is lowercase and then everything else is uppercase. What is it when they're all caps? Like every first letter is caps. Oh, whatever.
Is that Pascal case or something like that?
Maybe. Python's normally like this weird mixture of these. Like I always use snake case, but then for classes you do that. So it doesn't really matter. But you don't have to, but I do. That's convention. Anyway, so we're getting that. That's just a class that does a bunch of stuff. So we then can add a bunch of arguments. So I'm adding -- base path and -- word list. Just some help text. And then what you do is you say, right, now parse the arguments that were given from sys.argv, and it'll go and try and match up your the arguments you pass in to actual values that are useful. So if I now go space path and go HTTP, actually just for safety, I always have to type over a microphone and it's kind of like annoying. -- word list is just going to be word list dot text. Please work. Yes. So, right. So that takes it to kind of that level. You can go crazy from there, but Outpass makes doing arguments so much easier because otherwise you'd have to be like, right, here is a list of all of the keywords. Now, sysargv1, does that equal any of these? Yes, it's this one. If it's that one, right, you got to get this in the next field, and it gets a bit tedious. So all they've done in Outpass is do that for you, which is very convenient. I suppose if you dove through the like you can with .NET, you can go and inspect other classes. So this is Outpass. So it just takes a bunch of stuff, does a bunch of stuff, and it's handy. Always handy to know. Always handy sometimes to go and look at other people's code and see how it works. It's, to be honest with Python, that's a lot of how I learned some tricks, was just looking at other people's code. Anyway, so we're at this point now. We kind of have something functional. We could kind of do something with it. So I will jump back over to the other completed one I've got. Oh man, so many like windows open. Not that one. This one. So this one's basically the same set of code, but there's a difference. So one of the things you can do with gobuster and dirbuster is set the number of threads. So Python is normally single-threaded, like if you're running things in a single loop. However, it can support forking, so going out into separate threads to speed up processing. So if I've got my list of 1,000 words, in the other one I was just finishing editing, it's going to do each of those words in sequence, and it's going to take as long as it takes. You can accelerate that with threading. So threading means you split the work up over multiple independent processes, because the CPU and the computer I'm using is more than fast enough to handle doing more than one at a time. So Python itself has its own internal constraints and can only work so fast. Web requests can only happen so fast. The web server on the other end can handle multiple inbound requests. And in parallel, it's quite fast, but in series, it's quite slow. So you make a request, that one's got to finish before you can make the next one. So what if we could do a bunch at the same time? And so in Python, a super simple way of getting that working is using the pull functionality from multiprocessing. So all of this does is it's actually very simple. So I originally tried to have it in the class and stuff wasn't working, and I remembered how to use it properly. So all we do then is we've still got our arg parser, we're still parsing in all that stuff, we're still creating our dir spammer instance, and then we're going, hey, create a thread pool for us with 10 possible threads. And then in that pool, you're going to run and this might require some explaining a couple of times over, but pull.map effectively says this function, and this isn't a variable, this is pointing at a function. So in Python, if you stick the parentheses on the end of a function, you're calling that function. If you've got no parentheses, you're effectively referring to the object that the function is. So you could pass it around like a variable and say, hey, run this function over here, but I don't want to give you the output from the function. I want to give you the function to run yourself. That's what this is doing. And then I want you to run that over the word list in dirspammer. So rather than use, in the other one, we were using the check word list function. Now we're directly just using this because we don't need to use this. Because map handles kind of...
It separates it out into the number of pools and figures out.
So what happens if our word list is 1,000 and we've got 10 threads? The map function here breaks our 1,000 words up into 10 separate lists of 100 words. And then for each of those 10 lists, passes that to check URL path. So passes that to this function. So the thread now gets the function and 100 words to work on. It's kind of the same as if you were... what's the classic Google example for like... mapping. It's not called mapping in Hadoop. It was called something else. But effectively, you've got to count the number of books in the library. And you're given an instruction. And your instruction is literally just... every new book you see, books plus equals 1 or plus plus. Increment the book's value. And then... so mapper gives you the function. That, just increment this value. And then says... you're counting this bit of the library, and to someone else it says you're counting this bit, to someone else you're counting this bit. And that's all it's doing, is it's breaking up our job into multiple streams that can be done in parallel, and it's a lot quicker. And the advantage with like pull.map, rather than threading, like behind the scenes it's still threading, is threading you got to go and sit there and create thread classes and handle like...
if you've ever used, say, the .NET equivalent of multi-threading, you'll know that compared to this, it is a pain in the butt.
Yeah, so this means that if I run it here, we smashed through the list. So if I set this back to 1, you'll see how much longer it takes. So now we've got one thread. So effectively, we've made no difference. Going, done. If I set it to 10... and save.
And you might also notice the last few words in the output window.
They're all out of order. So, so one of the things is when you're threading, the results come back. So what happens is in each thread, they're now running this code. And this code prints stuff back out to the console. You could also have them... so pull.close and pull.join, if I was actually returning results, pull.join would collate all the results from the different threads so that you can sort through it. I'm pretty sure that's what it does.
When you're talking about the counting books in the library, that's where you wouldn't output anything until you've joined the pull back together... added the results together, and then you'd print the final total sort of thing.
But here we're just dumping out to console, so we're not really returning any results. But it does mean the results just come back in whatever order they did. So kind of semi-alphabetical, but you can see...
It's sort of where maybe one list was given all the W's and one thread, and then another thread was given all the S's, and then another thread, but separated into... those 10 lists of 100 words, and that's just how they they
come back all jumbled
happened
out
to respond. So
if you were concerned about the order, you'd need to then process those results to put them back in the right order. Otherwise, really, in a case like this, we don't really care. Like, it doesn't really matter. There are probably also ways of forcing it to process them in a better order, but we're kind of in this context, it doesn't really matter. You're just interested in seeing results back as they come. They don't necessarily need to be alphabetic unless your word list was ordered in like specifically frequency count. So this one is the most common, the last one is the least common.
I mean, you could do things like, instead of printing, add them to a dictionary, and then
Yeah.
you could order the dictionary based on sort of
Although,
the
funnily
word
enough,
word response key value type.
when I set it to 100 threads, it runs slower. So, because now that's 100
It's probably
threads with. Oh no, now that's faster. If I go 1,000, it's 1,000 threads with one word, and potentially
yeah.
that is going. This is where we can start to talk about overloading a server, because now
The
this is
amount of overhead that it takes to separate the word list
my
and figure all that stuff out
my
is
poor.
not worth.
Well, no, it's not that. It's my poor desktop web server, as well as probably
Plus
freaking out
that.
about the number of inbound requests.
I just got 1,000 in one hit instead of 10 in one hit. Yeah.
Yeah. So, yes. So, and that's why in like gobuster, you fine tune your threading. So for HTB, you could do it at the 150. If you're running a CTF on your own internal, like I've got a little ESX server that I spin like Von Hub VMs up on, and I can give them enough grunt to handle me smashing them. But if you're on a pen test or red teaming or bug bountying, you kind of both have to bear in mind that the thing that you're hitting might actually be already in production, or it's a test server. It still might be used in testing. As much as pen testing theory is no one else can use your server while we're using it, it's always been like, oh, we're still doing
Yeah.
testing as well. So bringing it down means you have to ask someone to bring it back up for you, which is a bit tedious. So you rate limit so that you don't smash stuff. And the other reason why is that, like, if they've already got anti-automation, like account lockouts and stuff like that, or kind of, what's Apache, like fail to ban going, you want to kind of go low and slow. So that is kind of that. If we can kind of go, and just do a quick, like, return response underscore code, and then we should just be able to see what happens when I go print results. Yeah, there we go. So
that's just a list of all of the response codes joined back together.
Yeah, I could have sat there and changed all of these into well, I can probably go if I go I mean, me doing that, you don't necessarily actually need to do that. I just do that out of habit, because some languages, if you don't explicitly zero out a variable, so C is a great example of this. If you don't explicitly like clear out a variable, and then you're using it in a loop, and then you run it to some sort of like error, like a previous state can make it through that you didn't want to make it through, and something ends up in the wrong place. So this is the habit. I don't think you actually need to do it. So, and then if I return results, and if I just add a plus, new line, add all of these, because print behind the scenes adds new lines. Actually, one of the things to note was talking about Python 2 and 3 earlier. In Python 2, to print something, it's just print something. In Python 3, print isn't a keyword, it's a function. So that's one of the key differences. Unless you import from Future, I think that kind of solves that. Sweet. So we get a massive list back of all of the results, which is fun. And then you could, for each result in results.
For each 2 words in.
My bad. It's not even for each. It's just 4.
Oh, it's just 4. Okay.
Too much PowerShell. Print caps. Print result. Sweet. So then if we run that, I don't want to do that. If we ran that again, sweet. We get everything you'd probably want to
So
do.
because your print adds a new line and you've also got a new line in your thing, that's
Yes.
what you were talking about before with the whole...
Yeah.
Yeah.
Yeah. So it all just depends on what you're doing. If you're writing to a file, you need to add a new line. And there we go.
Yes.
And then that's back in the correct order. If you notice, they're alphabetical again. However, if you're like it's a 30,000 word or a 3 million word list, like some of the word lists are, and you can't run that fast, you might just want to leave it giving you feedback as you go and returning res. So you kind of would go da 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 da, and then you'd go print that so that you get your feedback as you go, and then your results at the end.
Yeah.
And then in Python, you could use the JSON libraries to dump this out to a JSON file instead, or a CSV, or just a list. But that's kind of like something quick and easy to do. In some ways, it's kind of like some of the quick and dirty stuff I've written in Python. So in the dab box, which is where I use the multi-threading. If I can quickly look, what did I use it for? We are almost done though. So I used it for, so dab, what was the thing I used it for? It was for breaking it was for checking a bunch of ports to see if anything was listing on all the ports. So, but this was there was some API connection thing that would then let you do a ping to another specific port. So, I thread pulled that to speed it up. So lots of cool little utility scripts. If you want to try and brute force passwords for 7-zip files, which was another one I did where you're opening I couldn't get John the Ripper to work. Or not John the Ripper, the other one, the Linux one, Jack the Ripper. Whichever one, I couldn't get it to work because I couldn't install all the stuff to get the Jumbo version working. Was that what it was, Jake?
Yeah, that's John. Yeah.
So I just wrote a super simple Python script that literally just ran the 7-zip executable with a password, and I ran it through a password list and got it that way. So plenty of useful little things you can do in Python. So hopefully this has been an experience. I say experience, geez. Every time someone says, this is an experience, I'm like, oh gosh. No, I'm pretty sure getting shot in the foot's an experience.
Experience the power of Python.
This is just a mild distraction from the screaming monotony of life. So hopefully this has been a mild distraction from the screaming monotony of life, and you've learnt a bit. I will chuck this on Gist in GitHub, or actually you can't do Gists in like group repos. I'll figure out somewhere to dump it, and go, here's like the code. I might comment it up so it describes it a bit more. I might even turn it into a more full-featured sort of directory discovery or directory and file discovery tool. gobuster probably still runs faster because it's written in Go, and the less you have between your code and the CPU, the better, and Python's got to go through an interpreter. Although it does run all right. If you're using URL and stuff like that, the advantage is you're basically using C libraries. You're not using code that's also written in Python and so on and so forth. So there is some there. But yep, so there it is. That's kind of that. If I check the old YouTube to see if there's any more comments. No, all good. Thanks for watching, guys.
I think that's it. Thanks for watching.
Cheers. Have a good one.
See ya.
Bye.